Okay, find the t-value such that the area to the right tail is 0.02 with 9 degrees of freedom. We don't want to use tables. There's a t distribution calculator in statcrunch. So under the calculator menu, pull up the t distribution. Okay, now the t distribution well, it looks a little similar to the normal distribution, but the parameter is different. Instead of putting in a mean and a standard deviation, what you do is you put in a degrees of freedom. The t distribution always has a mean of 0, and it always has a standard deviation of 1. What the degrees of freedom do for the t distribution is it puts more probability out in the tails for a lower degree of freedom, and for a higher degree of freedom, it brings the probability into the center. So anyway, well, let's set the degree of freedom. We're asked for 9 degrees of freedom, so let's set that 9 degrees of freedom. We want the area in the right tail to be 0.02. So the right tail, we want the probably greater than or equal to some value to be equal to 0.02. This is the picture, and it gives us the cutoff. We'll take 3 decimal places, 2.398. No need to use a t-table. We want to find a t-value such that the area to the right on the right tail is 0.20 with 23 degrees of freedom. 23 degrees of freedom. We want the area to the right to be 0.20. Compute. Excellent. 0.857. Rounding up. 0.858. Find a t-value such the area to the left is 0.10 with 12 degrees of freedom. Hint, use symmetry. Don't worry about that. We don't need to use symmetry. We can just do it right into the calculator. The area to the left of the t-value is 0.10. We want 12 degrees of freedom, and we want 0.10. This is it. It's negative 1.356. Excellent. 95% confidence. Okay, now for confidence intervals, we'll use the between calculator. We want to find what cutoffs put 95% in the middle. Just like we did with the z calculator, we'll do it here. We just have to set the degrees of freedom to be 22, and we put the area between to be 0.95. It will figure out symmetric cutoffs that achieve this. So let's take this critical t-value. It's 2.074. I'd have to round it to 0.4. Great. And we're done.